this expression LST is the local solar time, which is equal to LSTT, this is the local standard time. Okay. EOT, as you know, is nothing but equation of time plus 4 into LON minus LSM. LON is nothing but the local longitude, LSM is a local standard meridian. Okay. Let me give a very simple example. For example, for the city of Kolkata, Kolkata is located at 22.82 latitude, north latitude, and its longitude is 88 degrees 20 minutes east. Okay, this is the longitude, right? And the local standard meridian for India is 82 degrees 30 minutes, 82.5 degrees. Okay. So, this is the data, and we would like to find out on October 21st if the local standard time is 9 am. Okay, then what is the local solar time for Kolkata? Okay. So, for this particular day, that is October 21st, from the empirical equation for EOT or from the table for EOT, you will find that the equation of time is given by 15 minutes. Okay. So, EOT is given as 15 minutes. So, the local solar time is nothing but local standard time plus 15 minutes, 15 minutes is your EOT, okay, plus this is the correction for longitude variation between the LSM and LON. Okay. So, our local longitude is 88.33 degrees, whereas the local standard meridian is 82.5 degrees. Okay. So, this is the correction for that. So, if you substitute the values, you find that local solar time is now 9 hours 38.32 minutes, whereas the local standard time is 9 am. Okay. Since this is 9 hours 38.32 minutes in the morning, the corresponding hour angle is 324.6 degrees centigrade. How did I calculate the hour angle? As I said, at noon, okay, noon means let us say 12 o'clock, okay, 12 o'clock solar time, solar noon, your hour angle is 0. Okay. So, for example, at 1 p.m. the hour angle is equal to 15 degrees centigrade. How is it so? Because it makes the hour angle varies from 0 to 360 degrees in 24 hours. Okay. So, 1 hour is equivalent to 15 degrees. So, if it is if you are starting with noon, then afternoon it will be starting with 0 at noon, afternoon hours will be, let us say 3 p.m. means 45 degrees, okay, 4 p.m. means 60 degrees, like that. And if you proceed in that manner, you find that in the mornings, for example 9 am, 9 am means 3 hours before solar noon, okay, that means it is 360 minus 45, that is 315 degrees centigrade. Okay. So, now the local solar time in this example is 9 hour 38.32 minutes. So, the solar angle is 324.6 degrees. Okay. So, that is how you can calculate the hour angle. So, what you have to do to calculate hour angle is to first find out what is the local longitude, and you also should know what is the local standard meridian, right, and then if you know the local standard time and equation of time, then you can calculate, first you should calculate the local solar time, and once you know the local solar time, you can calculate the hour angle, because 1 hour is equivalent to 15 degrees. Okay. Okay. So, the hour angle, as I said, is based on local solar time, and the declination varies in an approximately sinusoidal fashion. I have mentioned that the declination varies from plus 23.5 degrees to minus 23.5 degrees, and the variation is almost sinusoidal. Okay. So, you can fit an empirical equation. So, this is an empirical equation for declination, okay, declination d in degrees, this in degrees, it's all the angles are in degrees. Okay, this is very important, keep in mind. Okay, so your unit should be consistent. So, declination in degrees is given by this empirical equation 23.47 into sine 360 into 284 plus n divided by 365. What is n? N is the day of the year counted from January 1st. That means January 1st n is equal to 1, January 2nd n is equal to 2, like that. So, December 31st n becomes 365. Okay. So, if you know the day of the year, you can easily calculate the declination using this equation. Okay. And from this equation you will find that on June 21st, okay, on June 21st you find that declination d is approximately equal to 23.5 degrees, and on December 21st, okay, this is equal to minus 23.5 degrees. Okay. For example, I want to calculate the declination for March 6th. Okay. March 6 happens to be the 65th day of the year, that means n is 65. So, all that you have to do is substitute the value of n here. So, you will find that the declination on March 6th is minus 6.4 degrees, okay, from the above equation. Okay, so these are the basic solar angles. Now let us look at derived solar angles. In addition to the basic solar angles, several other angles required for solar radiation calculations are derived. First one is what is known as altitude angle. So let us see what is this altitude angle. Okay, let me explain this figure. Let us say that this is an horizontal plane. Okay, so this is the point P is the position of the observer, okay, and let this be the north and south sides, and this is the west and east sides. Okay, so you have north, south, east, west, right, and this is the path of the apparent sun path. That means this is the path of the sun as it appears to the observer who is located at point P. So as you can see that sun rises at this point. Okay, sun rises in the east and follows this path. This is for a particular day. Okay, this path is not constant; it varies again from day to day. So for a particular day, let us say that this is the sun path. So it rises in the east and it sets in the west. Okay. Now with reference to this figure, what is the altitude angle? Altitude angle is given by beta. Beta is the angle between sun's rays and its projection on a horizontal plane. So this is your sun ray. This is your sun and this is the sun ray. So beta is nothing but the angle between this sun ray and its projection on the horizontal plane. The projection of the sun's ray on horizontal plane is this. Okay. So altitude angle is nothing but this angle, that is beta. Okay. So as you can see that beta is 0 at sunrise. Okay. So at this point the sun ray, the direction of the sun ray and its projection coincide. So beta will be 0. Similarly, beta will be 0 at sunset. Okay, so at these 2 points, beta will remain 0, and it reaches maximum at solar noon. Okay, in fact, that is the definition of solar noon. At solar noon, you will find that the altitude angle is maximum. So this is the first angle. The second angle is what is known as zenith angle. So zenith angle, I am sorry, this should have been psi. This is. Zenith angle is given by this symbol, is the angle between sun's rays and the surface normal. Okay, sun rays, as I said, this is the sun ray, and the normal to the surface at point P is this. Okay, so the zenith angle is nothing but this angle. Okay, so this is the zenith angle. Obviously, zenith angle plus altitude angle should be equal to 90 degrees. Okay, so this angle is equal to 90 degrees. That means the zenith angle is equal to 90 minus beta. So if you know the altitude angle, you can find out the zenith angle easily. Next important angle is what is known as solar azimuth angle. Again we refer to the same figure, and the solar azimuth angle gamma is the angle between the north and the projection of sun's rays onto the horizontal plane. Okay, so what is so as I said, this is your north direction. Okay, so azimuth angle is nothing but this and the projection of sun's rays onto a horizontal plane. The projection of sun's rays onto a horizontal plane is this line. Okay, so the azimuth angle is the angle between this line and this line. Okay, so as you can see, that is nothing but this angle. Okay, this angle is given by gamma, and this is measured in counterclockwise direction. Of course, this varies, this convention varies from textbook to textbook. Some people define the solar azimuth angle with reference to the south direction. Okay, some people define it with reference to the north direction, and sometimes it is defined in terms of the clockwise direction from north, and in some books it is defined in terms of anti-clockwise direction from the north. And in some other books it is defined for forenoon it is in the clockwise direction, and for afternoon it is in the anti-clockwise direction. So the definitions vary, but basically once you have this diagram, it is easy to understand and it is easy to change from one convention to the other convention. Okay. So in this particular lecture I am following the convention of measuring it from the north in the counterclockwise direction. Okay. So, this is the solar azimuth angle gamma. Now, using analytical geometry, it is possible to derive relationships between derived and basic solar angles. This is important, the relationships between various angles. Okay, so altitude angle beta. So, beta, it can be shown that beta, the altitude angle beta is equal to cos L multiplied by cos H multiplied by cos D plus sin L multiplied by sin D, where L, as I have already discussed, is latitude, H is the hour angle, and your D is declination. Okay. So, you can see that the altitude angle is simply related to the basic solar angles of latitude, hour angle and declination. That means, the altitude angle depends upon the day of the year, time of the day and the location of the point. Okay. And as we know, at solar noon the hour angle is 0, that means cos H is equal to 0, right. So, when H is equal to 0, as you know, cos H is 1. Okay. Then you find that the altitude angle is maximum and that value is given by beta max. Beta max is simply equal to pi by 2 minus L minus D. Okay. This is your absolute value of L minus D, where L is the latitude and D is the declination. Okay. So, once you know the latitude and declination, you can calculate what is the maximum altitude angle on any given day. For example, for Kolkata, again take the example of Kolkata. For Kolkata, the latitude is 22 degrees 82 minutes north, and I want to find out what is the maximum altitude angle on June 21st. Okay. And as we know, on June 21st the declination D is 23.5 degrees. Okay. So, beta max is nothing but pi by 2 minus 22.82 minus 23.5. Okay, you have to take the absolute value of that, then you will find that this is equal to 89.3 degrees. Okay, this is the maximum altitude angle, is almost close to 90 degrees. Okay, on June 21st for Kolkata, and you can see that the beta max is equal to 90 degrees when L becomes D. Okay. So, D, as we know, is that means when the latitude becomes equal to declination, the beta max becomes 90 degrees. Okay. Next, there is another important information that you can get from this equation, that is that at sunrise and sunset we know that the altitude angle beta is 0. Okay. So, beta is 0 at sunrise and sunset, as I have already explained to you. So, we can find out what is the time of sunrise and sunset using this equation. Okay. How? If you substitute value for beta as 0 here, you can find out the hour angle at which sun rises and sun sets. Okay. And that hour angle is given by this expression. This is derived from this equation. Okay. This is derived from this equation by taking beta is equal to 0. So, H naught is the hour angle at which the sun rises or sun sets. So, that is given by cos inverse minus tan L into tan D, where L, as you know, is the latitude and D is the declination. Okay. Let me give a small example. For example, I would like to find out the sunrise, sunset and total sunshine hours at IIT Kharagpur on September 9th. Okay. So, I would like to find out at what time the sun rises and the sun sets and what is the total sunshine hour, that means how many hours the sunshine is available at this particular location, which has a latitude of 22 degrees. Okay. That means L is equal to 22 degrees north. Okay. So, first as you have seen, H naught from the earlier this thing is tan. Okay. So, as you can see from this expression, H naught is cos inverse tan L into tan D. So, we have to find out what is the latitude and we have to find out what is the declination. Latitude is given as 22 degrees. So, I have to find out the declination on this particular day, September 9th. So, all that I need to know is what is the number of the day. So, if you start counting from January 1st, you will find that September 9th happens to be the 252nd day of the year. So, n is equal to 252. So, if you substitute n is 252 in the expression for declination, you find that the declination angle is equal to 4.62 degrees. Okay. So, if you substitute 4.62 degrees in this expression, you find that the hour angle at sunrise and sunset is equal to 91.87 degrees. Okay. Since each 15 degrees is equal to 1 hour, 91.87 degrees is equal to 6 hours and 8 minutes. Okay. Right. So, the hour angle is equivalent to 6 hours and 8 minutes. What is the meaning of this? This means that the sunrise takes place at 12 minus 6.08, that is 5.52 hours in the morning. This is the solar time, and sunset takes place at 12 plus 6.08, that is 6.08 pm, right. So, sunrise is at 5.52 am and sunset is 6.08 pm, okay, and both are with reference to solar times, and the total sunshine hours are nothing but 2 into h naught, 2 into h naught by 15, let us say, since h naught is in degrees, this will give you the total sunshine hours. Okay. So, you can see the usefulness of this equation. Okay. This simple and elegant equation can be used to find out at what time the sun rises or sunset at any location on the earth on any particular day. Okay. And you can also calculate the total sunshine hours. This information is very useful in the design of several solar energy equipment, and it is also useful in air conditioning for load calculations. Okay. So, this is the relationship between altitude angle and the basic angles and the usefulness of this equation. Now, let us look at the other equation, that is the equation for solar azimuth angle in terms of the basic angles. So, solar azimuth angle, this as I have mentioned is as measured from north in a counterclockwise direction, right. So, that is if you take that convention, then this is given by gamma is equal to cos inverse cos L into sin D minus cos D into cos H into sin L divided by cos beta. As you know, again L is the latitude, D is the declination, H is the hour angle, and beta is the altitude angle. Okay, so this is defined in terms of, again that means this is again a function of the basic angles only, because beta is a function of basic angles L, D and H, right. So, this you also have an alternate expression, this is also equal to sin inverse cos D into sin H by cos beta. These two expressions are equal, so that you can easily prove by using your trigonometric relations. Okay, so this is the relationship between solar azimuth and other angles. And one important thing to note here is that solar noon, that means when H is equal to 0, gamma is 180 degrees, for L is greater than D, that means when the latitude angle is greater than the declination angle, then we have to take gamma as 180 degrees, and gamma should be taken as 0 degrees for L is less than D. Okay, so this you must keep in mind. Okay, so only for solar noon you have to keep this information, and gamma is not defined for L is equal to D at solar noon from this equation. Okay. Now, let us look at the incident angle of solar radiation, that is theta. So, as I have already mentioned, the incident angle of sun's rays theta is the angle between sun's rays and the normal to the surface under consideration. The angle of incidence theta depends on solar geometry and also on the orientation of the surface. For example, let us look at a horizontal surface, theta is equal to zenith angle. This can be shown very easily if you look at this figure. So, this is your horizontal surface, and by definition theta is your angle of incidence, which as I said is defined as the angle between the sun's rays and the surface normal. Okay, since this is a horizontal surface, this is the surface normal, and this is your angle of incidence, and it so happens that the angle of incidence for horizontal surface is also equal to your zenith angle. Okay, zenith angle, and as we know phi plus beta is xi plus beta is 90 degrees centigrade, 90 degrees. So, theta is equal to pi by 2 minus beta. Okay. So, if the surface is horizontal, then once you know the altitude angle, you can easily find out what is the angle of incidence. How this information is useful? For example, I want to calculate what is the radiation incident on the roof, on a flat roof. Okay, a flat roof means it is a horizontal surface. So, all that I have to do is on a particular day at a particular time, because it is a function of the time of the day, location of the surface and the day of the year. Okay, so all these things, for these once you know